In this session, let us discuss about data types in C++. What are the different data types available in C++? See, first of all, to begin with a data type. So what is data type? To understand any programming languages, first we need to understand the elementary concepts which forms the building block of that program. So the basic building blocks includes variables, data types, many more. So this C++ provides a set of data types so that you can handle the data that is used by the program. So let us begin with a variable. What is a variable? A variable is nothing but an object or element which is allowed means and it will allow to change during the execution of the program. Means a variable is an object or element and it is allowed to change during the execution of the program. The name itself tells variable, so it varies. So variable represents the name of the memory location. So how do you declare a variable? What is the syntax for declaring a variable? So the declaration is data type, variable name. So what are the different data types? We know integer, float, char, double. So that should be specified here. What type of data are you storing? So the followed by variable name. What is the name of that variable name? So that is the name for the memory location you're giving. So type of the variable is very, very important because a particular memory location is designated to save one particular data. That is, integer can store only integer memory, integer variable you have declared means that memory location can store only integer data types. Float and char similar way. So the variable name is an identifier. We know what are the rules for the identifier. Let us discuss one by one. So these variables are used to denote constants, arrays, functions, structures, classes, and files. So the variables are named storage location whose values can be manipulated during program run. Let us discuss some examples. So valid examples, for example, register number, marks, name, student one name, date of birth. See, these are the variable names, valid variable names, because one thing is you can give int A, int B, int C like that, but instead of giving A, B, C, the identifier should be named properly so that it should be self-explanatory. Means it should give some meaningful name. That's why valid variable names. I have given some example like this. So looking at this, we can understand this variable speaks about register number, this variable speaks about something marks, and this speaks about name of a person, this student, and date of birth like that. So invalid variables. So there are certain rules to write, to declare a variable. Double, you cannot use this because it's a reserved keyword. Keywords cannot be used, cannot be named of the variable. So total marks here, it's not a keyword, but you have given space. So empty space is not allowed between variable names. See, it's total marks. So there should be no empty space. But here, so it's not valid. See, to student. So variable name should begin with an alphabet, but not a number like this numerical. So here, it's not a valid. Question mark result, that is variable should begin with the alphabet or underscore only. So you have given special character, that's why it's not at all possible. Question mark, it's an operator, you cannot use this. So how do you initialize a variable? So syntax to initialize a variable is the data type, variable name is equal to value, to which value you are going to initialize this variable. That value should be written as, for example, int int or any number. For example, int marks is equal to 30. So that 30 will be the value which is stored in the marks variable. That's why. So data type, int, float, char like that. Variable name. What is it? Name of that variable, and is equal to assignment operator it is, and it is value. So this value will be assigned to this variable name using this assignment operator. So now let us discuss with a simple programming, simple example. So B be a variable declared and it's of type 10. So I have declared a variable called B of type integer and I have assigned a value of 100. So there are two values associated with a variable known as L value and R value. It means, for example, let P be a variable declared of the type integer. Okay, P is equal to 100. Here, name of the variable is P, values assigned to variable is 100. That is R value memory address location is 2000. That is L value is the location value. It holds the, what is L value and R value? L value is the location value. It holds the memory address location at which the data value is to be stored. R value is the data value. It holds the value assigned to the variable by the programmer. That is R value of P is 100, like that. So C++ compiler allows us to declare a variable at runtime. So this is dynamic initialization. They can be initialized anywhere in the program before they are used. The access modifier const, you can see here within quotes have written const prefixed along with the data type. For a variable does not allow the value to be changed at all throughout the program because we have made that as a const. So const int a is equal to 100. Like this, you have to declare any variable if it remains to be constant. The keyword const becomes an access modifier for the variables. So first of all, a value can be assigned to L value only in an expression. So value can be assigned to a variable using the assignment operator is equal to. So the expression to the left of an assignment operator should always be an L value, that is memory location, because that memory location should be available to store the R value. So constant identifiers can appear to the right of the assignment operator only, because they are not L values. Next, coming to data types. So data types can be defined as a set of values which can be stored in a variable along with the operation that can be performed on those values. The main aim of C++ program is to manipulate data. C++ defines several types of data and each type has unique characteristics. So C++ data types can be classified as fundamental data type, derived data type, user-defined data type. So coming to fundamental, the simple or fundamental data types are the primary data types which are not composed of any other data types. So the simple data types, fundamental data types includes int, char, float, double, and void. You can see the chart here, that is C++ data types is divided into three types: fundamental data types, derived, and user-defined. Under fundamental data types, integer, character, float, double, void, and boolean comes. Under derived data type, array, functions, pointers, references will come. Under user-defined data types, structure, union, class, enumerations. This is the hierarchy of C++ data types. So first, integer type. So int type is used to store integers. Integers are whole numbers without any fractional parts. So this includes numbers such as 1, 45, -9, -8, like that. These are all integers. So 5.2 is not an integer because it contains a decimal point, that is 0.2. You can see this. The integer can be positive or negative values, and the ranges of number we can store or from the range I have given here, -327862 to 32767. So this is the range we can store the numbers. An integer is allocated 2 bytes, that is 16 bits of memory space. The possible operations include addition, subtraction, multiplication, division, remainder, so many. So what is a general format for integer declaration? See, data type, variable name. So type of the variable should be int because it is an integer data type. Int variable name, int a. or b is equal to 5. So here, comma, this b is also of type integer. So a and b are the variables of type integer, and b is assigned with the value 5. You can initialize at the time of declaration itself. Next comes char type. It is character data type to store any character from the basic character set. Characters are enclosed in single quotation marks like this. You can see here. These are all character constants. So when a variable of type char is declared, the compiler converts the character to its equivalent ASCII code. The character is allocated only 1 byte of memory space. That's 1 byte means 8 bits. You should remember that. A character is represented in a program by the keyword char. So char is a keyword to represent the character data type. So what's the general form of character declaration? You can see data type is char followed by variable name. Char variable list. So similarly, char, you can also initialize character variable like this. Char alpha. Alpha is a variable name of type character, and it is initialized to a. Next, float type. This represents the number with the fractional parts, that is real numbers. So these types are used to store real numbers, such as 1.8, 4.5, like that, minus 9.6. So you can see the floating point number, that is decimals. It can also be both positive or negative. The range of numbers we can store here, I have given the range. So this float is allocated 4 bytes of memory space. That is 32 bits of memory space will be allocated for this data, for this particular data types. The general form of float declaration is data type followed by variable name. So data type is float variable name. Example, float A. A is of type, A is a variable of type float, and it is initialized to 5.5. So double type. The double and float are very similar. The float type allows you to store single precision floating point numbers, while the double keyword allows you to store double precision floating point numbers. So its size is typically 8 bytes of memory space. The range I've shown here. The general form of double declaration is double followed by variable name. So this is actually the variable of type double. So you can store large value. It's equivalent to, this value is equivalent to 5.5 into 10 raised to minus 7. So next comes void type. The void data type has no values and no operations. In other words, both the set of values and set of operations are empty. How do you declare that void type? So void is a keyword, void main. So this is an example. In this declaration, the main is a function which does not return any value. Next comes bool type. Bool type has logical value, that is true or false. The identifier true as the value 1 and the identifier false as the value 0. The general form of a bool operation or declaration is bool followed by variable name. Bool followed by variable name. So this is bool. This name of the variable of type bool. So it is assigned to true. So the statement legal age is equal to age greater than or equal to 21. See, this statement assigns the value true if age is greater than or equal to 21, or else it returns the value false. So you can see here the size int, char, float, double, like the size in bytes and ranges of that, and examples. These are the examples. So derived data types. So derived data types is, these data types are constructed using simple or fundamental data types. This includes arrays, functions, pointers, and references. So user-defined data types, these data types are also constructed using simple or fundamental data types. Some user-defined data types include structure, union, class, which I have discussed already. So coming to an enumerated data type. An enumeration is a user-defined type consisting of a set of named constants called enumerators. So enum is a keyword which assigns the value 0, 1, 2, 3 like this automatically. This helps in providing an alternative means for creating symbolic constants. So syntax for enum is as follows. You can see enum is a keyword. You have to tag an enum list. So the name of the enumerator is this. Example for enum is a keyword. This is the name of the enumerated choice. Very bad, bad, satisfied. So it's assigned automatically 1, 2, 0, 1, 2, 3, 4 like this. So how do you declare this is choice, my choice. So like that we can declare our own user-defined data. Now enum, for next example 2 is enum, my enum type, alpha, beta, gamma. So here alpha takes the value 0, beta takes the value 1, gamma takes the value 2. Like that example 3, enum foot size. So here small takes the, here I have assigned. We can also assign explicitly the values to the enumerator list. C++ enum type conversion rules. You have to follow certain rules while writing the enumerated data types. So these rules apply to C++ only. There is an implicit conversion from any enum type to int. Suppose this type exists. So enum, my enum type, then here alpha, beta, gamma are not declared. So automatically it assigns 0, 1, 2 to this list. The following, this is the valid example. Now we can also do like this. Int I is equal to beta. Here, after declaring this is the enumerated data. Now int I is equal to beta. So here I value of 1 means it gives I value of 1 in j is equal to 3 plus gamma gives j value of 5. On the other hand, C++ does not support any implicit conversion from int to an enum type. This type conversion is always illegal. See here, int I is equal to beta. Next, if I write int j is equal to 3 plus gamma, then j value becomes automatically 5. Here I value becomes 1 because beta is 0, 1, 2. It's already assigned. Alpha value is already 0. Where beta value is 1, gamma value is 3. So beta, since you have written int I is equal to beta, beta becomes 1. That 1 value is assigned to I. So I value becomes 1. Now if I write int j is equal to 3 plus gamma, then this j becomes 3 plus gamma value is 2. That's why 3 plus 2, 5. So j value becomes 5. Like this, actually it happens. But here, this is my enum type. X is equal to 2 should not be allowed by the compiler because you're assigning directly the value. You cannot do it. This is also should not be allowed by the compiler. Similar way. Note that it does not matter whether the int matches one of the constants of the num types. Thanks for watching. For more such videos, you can subscribe to our YouTube channel.